All right, time to talk about something really important called normalization. Now, this is a tricky one to wrap your head around at first, so I'd encourage you to rewatch this video as many times as it takes until it starts to really stick. So, by definition, normalization is the process of organizing the tables and columns in a relational database to reduce redundancy and preserve data integrity. So, a lot of fancy words there, kind of tough to understand what that really means, but basically it's used to do three different things. Number one, eliminate redundant data, which helps to decrease table sizes and, more importantly, reduce processing speed and improve efficiency. Number two, helps us minimize errors and anomalies when we make data modifications. So if we need to insert or update or delete records in our database. And number three, it helps simplify queries and structure the database in a way that enables meaningful, useful analysis. So still feels kind of overcomplicated if you ask me. So my tip to remember what normalization is all about is to think of it this way. In a properly normalized database, every table should serve a distinct and specific purpose. So you might have one table that only gives you information about products. You might have another that only gives you information about dates, like a calendar table. You might have one that's only daily transactional records and another that's only about customers. Now, this should sound pretty familiar because these are the exact type of tables that we're using here in this AdventureWorks demo. So let me take a stab at visualizing why normalization is such an important concept. Consider a table like this. You've got transaction quantities here in the third column, broken down by product ID and by date, as well as all of this extra information about each product ID, the brand, the name, the SKU, and the weight. And as you can see just from this small sample, that we have multiple transactions or multiple quantity values per day and multiple quantity values per product ID. So this table is not normalized. It doesn't serve a single unique purpose. It's actually serving at least two purposes. One, providing the transaction quantity by date and product ID, and two, providing additional attributes about those products. Those are two different purposes. So what you end up with here are all of these duplicate rows in any case where the same product ID appears more than once. So you see duplicate brand names, product names, duplicate SKUs and product weights. And you might be wondering, okay, that's not that big a deal. I'm still getting the information that I need. In fact, I have it all in one place in a single table, which is great, so I don't see the downside here. Well, imagine if we were dealing with 100 different products, and each of those products, on average, sold 10,000 times a day. Now all of a sudden you're talking about 1 million duplicate rows for every single date in the data set. So you can see that with larger or more complex models, minor inefficiencies like this can become major problems as you scale up in size. So the way to avoid issues like this is to strip those product attribute columns out of this table and create a relationship with a single product lookup. And if that product lookup contains a unique list of product IDs with those associated attributes, then we can access the exact same information here while eliminating every one of those duplicate rows. So again, this concept may still feel a little bit ambiguous, but trust me, we're going to get our hands dirty. We're going to do a ton of demos, walk through a bunch of samples, and this is going to start to feel much more natural as we continue through this section of the course. So next up, we're going to talk about data tables and lookup tables as our first step towards building a properly normalized model.